Hi everyone, welcome to MedTV. Today we are exploring the basic yet fundamental problem in two-dimensional motion. So we will look at two problems, which is projectile motion and a motion on an inclined plane with friction. So let's look at the first problem. So we have a ball thrown from the ground with initial velocity of 20 meters per second at an angle of 30 degrees above the horizontal. Now we need to find the maximum height reached by the ball and the total time of flight. So when we get this type of question, what we need to do first is to break down the initial velocity into horizontal and vertical component using trig. So as you can see from here, you can see I've drawn a diagram here. You can see we have the vertical component of the projectile and we have the horizontal component of the projectile. Now let's say someone was standing here and the person threw an object into the sky. Now the object will go higher. Now to get to the point in the sky where the object will stop and come back into the ground. Now at this point there's a maximum height which is obtained or reached, and that's what we are going to look for. Now the time whereby the ball was thrown into the sky and came back into the ground is called a time of flight, and that's what we are going to look for. So these are the two questions that we are going to look at: the maximum height and the time of flight obtained. So as I said, before you can solve this question, we need to break down the initial velocity into horizontal and vertical components using the trig. So let's look at our horizontal and vertical component, or the initial velocity. So with our horizontal component of the initial velocity, we are going to have v initial x, which is the horizontal, being equal to the v initial cos theta. Now we know that our v initial, or the initial velocity, is equal to 20 meters per second, and our theta here is equal to 30 degrees. So we can go ahead and find our initial component of the horizontal. So with that, we are going to have 20 multiplying cos 30 degrees, and we will get 20 multiplying root of 3 on 2, and our final answer will be 10 root 3 meters per second. So that is the initial velocity of the horizontal component. So v naught x. Now let's look at our initial velocity of the vertical component. So that will be v naught y, so equal to v naught sine theta. We know our theta, we know our v naught, so we have v naught y 20 sine theta, which is 30 degrees. Then when we do it, we should get 20 multiplying half, and our answer will be 10 meters per second. So this is our vertical and horizontal component of the initial velocity. Now the next thing that we need to do is to go to our main, what we are asked to find. That's the maximum height. Now to find the maximum height, we use the vertical motion equation. So at the maximum height, the vertical velocity is 0. So the vertical velocity is 0. So we have our vertical velocity to be 0. So we use the kinematic equation, which is Vy exponent of Vy squared being equal to the V naught y squared minus 2 chain h maximum. So the Vy here is the vertical velocity, right? And our gravity here, which is 9.8. So G here is 9.8. So we just go ahead and do it. So we have 0 squared being equal to 10 squared minus 2 multiplying 9.8, then the maximum height. We can bring the 2 times 9.8 here, and 10 squared is 100. And when we do it, we should get 19.6. So we have our maximum height here. Maximum height being equal to 100. Now we are finding our maximum height, so we should get maximum height should be equal to 100 divided by 19.6, which is approximately 5.1 meters. Now let's look at our next one, which is the time of flight. That's the total time traveled by the object into the sky and back to the ground, right? So since the time to raise the maximum height is the same as the time taken to fall back or fall down, the total time of flight is going to be total time t total being equal to 2t up, right? So our t up is equal to v naught y on g, which is the gravitational force. So that will be 10 on 9.8, which is approximately 1.02 seconds. And we said our total time should be equal to the total time equal to 2 times up, and we have 2 times 1.02, and our answer will be 2.04 seconds. So the maximum height reached by the ball is approximately 5.1 meters, and the total time of flight is about 2.04 seconds. Let's go to our next question. So in our next question, we have a problem which says 5-kilogram block sliding down a frictional inclined plane, making an angle of 45 degrees with a horizontal. Now, the coefficient of the kinetic friction between the block and the plane is 0.3. So here we need to find the acceleration of the block and the distance traveled after 3 seconds. So first, let's identify the force acting on the block and the gravitational force that can be broken into both parallel and perpendicular. So if you look at our diagram here, you can see this is the block here. This is our parallel component of the force, and this is our perpendicular component of the force. This is our frictional force, and this is our gravitational force acting on it. So let's break them down. So breaking them down, the gravitational force, which is the Fg here, should be equal to mg, right? And we have m here to be 5, and we have our g here to be 9.8. So Fg here is equal to 5 times 9.8. So Fg is 49 newtons. Very easy. Now let's look at our parallel component of the gravitational force. So the parallel component, so I'll represent it as G, which will be Fg sine theta. We know our Fg, which is 49, then sine theta. The theta here is 45 degrees. So 45 degrees. And when we do it, we should get 49 times. So sine 45 is root 2 on 2. And when we do it, we should get 34.6 Newton. That's the parallel component of the gravitational force. So let's look at the perpendicular component of the gravitational force. So with that one, we should get F, I'll present it like this. Then we get Fg cos theta. We know Fg to be 49. We know our theta to be 45 degrees. So F perpendicular G should be equal to 49 cos 45 degrees. So 49 times, so cos 45 degrees is root 2 on 2. And with this one, we should get 34.6 Newton. That's the perpendicular component of the gravitational force. Now, when we are done with it, the next step that we need to do is to find the normal force N, which is the Fn, which is equal to the perpendicular component of the gravitational force. Therefore, F perpendicular component should be equal to the normal force. And we know our perpendicular force here is 34, so 34.6 Newton. Very easy. Now, when we are done with this, we have to find the frictional force. So we know that the frictional force is equal to K, then the normal force. That's the coefficient. So we know our coefficient here to be 0.3. We know our normal force to be 34.6 Newton. So our frictional force will be 0.3 times 34.6. So our frictional force will be 10.38 Newtons. Now, when we are done, then we will find our net force and the acceleration. So let's find our net force first, then we'll find our acceleration. So with our net force, so F net will be the Fg parallel, that's the gravitational force parallel, minus the frictional force. We know our parallel gravitational force to be 34.6, frictional force to be 10.38. So our net force will be 34.6 minus 10.38. So our net force will be 24.22 Newtons. Then to find our acceleration, we have to use the Newton's second law. So with the Newton's second law, the acceleration is going to be the net force on the mass. So we have 24.22 on 5. And our acceleration will be 4.84 meters per second squared. Now, at this point, we can find our distance traveled after 3 seconds. So let me use this part. So the distance traveled. So we can use, after 3 seconds, we can use D should be equal to V naught T plus 1/2 AT squared. So we know T to be 3 seconds. We know V naught to be 4.84, right? And we know our A here to be 9. So we can, D here should be half times 4.84 times 3 squared. So we have our D here to be 21.78 meters. So the acceleration of the block is 4.84 meters per second, and the distance traveled after 3 seconds is 21.78 meters. Thank you for watching. If you enjoyed this video, make sure you like it, comment, and subscribe to more physics problems. See you in my next video of part 2 of these problems. We are going to solve a lot of questions regarding this two-dimensional motion. So if you didn't understand this, watch out for more videos of this. Thank you, and I'll see you in my next video.